blessed and honored with two great scientists from Baba Atomic Research Center. Dr. C.V. Krishnan, he is the guest of honor, and Dr. A.P. Jayaraman, he is our mentor of this entire project. Every Saturday, in the sense like one Saturday in every month, the first Saturday in every month, we will hold any one topic which is relevant to our school education system related with science and technology. So let me start the program. And these all are award winners. These all are mentors. And let us start with a small prayer. Welcome back. I'll just put a small video of 2 minutes about CAR. Please watch it. Only 2 minutes.
Center for Educational Initiatives and Research, CEIR Global Trust, has established a common platform for educators, students, principals, parents, and management so as to improve the overall school culture in India and abroad. Since its inception from 2009, CEIR has conducted many and extraordinary programs for the target groups right from K1 to K12. All CEIR programs are powered by Veda Handwriting Lab. Veda offers multiple programs for students and teachers. These programs are backed by scientific research. At Veda Handwriting Lab, we say good or bad handwriting is an existing myth. There is only trained or untrained handwriting. To make it possible, Veda Handwriting Lab has developed a training device called Manicule Memory Board for faster and long-lasting results among students and teachers. Handwriting Elite Kit and Life Kit are the flagship programs for Veda Handwriting Lab, accessible through our website www.vedahandwritingkit.com. Now also available on Amazon. We believe that we will be a force to reckon with the near future. We believe that the best is yet to be. The ultimate aim of the CEIR is to create a CEIR Center of Excellence by 2030, a perfect away from home to home its members. Vande Guru.
So now let me invite our today's moderator and mentor of this project, Dr. A.P. Jayaraman, nuclear scientist, Bath. Sir, please. Jayaraman, sir, please.
Yes. Am I audible?
Yes, sir. Yes, sir. Perfect.
Thank you, Dr. Srisan Gopinath, for making this event happen. Dr. Mahajan here and the great movers and shakers of the movement CEIR. I welcome all of you for giving us this opportunity to be here with you and to speak about science and technology and experiential learning. My job is as moderator, and the word moderator has a nuclear connotation. The average logarithmic energy decrement per collision should be the highest. That is the property of a moderator as far as nuclear physics is concerned. When the presenters increase the speed of their presentation, my business is to attenuate it, to reduce it. And that is what heavy water does in a nuclear reactor. I will try to perform the function of a heavy water moderated reactor. Now, my first duty here is to introduce the guest of honor, a very distinguished person. All of you would have heard about Dr. C.V. Raman. C.V. Raman produced new knowledge. Production of knowledge is one thing, but Dr. C.V. Krishnan produced not only new knowledge, but distributed that knowledge. Production of knowledge is one aspect of science, but distribution is a more important, strategically important function, which he has been doing in an extremely illuminating way. There is an intensely inspired inevitability as far as his distribution of knowledge is concerned, and the United States President rewarded him for that. Now, to do something in science, to produce new knowledge, yes, C.V. Raman has done that. But to explain C.V. Raman to the common people in a language which they can understand, assimilate, and absorb into their daily life, that is where distribution comes. And we as teachers are distributors of knowledge. And to me, an exceptionally good model of a science teacher is Dr. C.V. Krishnan. He is senior to me in the Atomic Energy Establishment, being from the first batch of the training school of the Atomic Energy Commission. Atomic Energy Establishment, Homi Bhabha said in 1943 that when nuclear energy has been successfully applied for power production, in a couple of days, a couple of years from now, India will not have to look abroad for its efforts and started a training school. So from colleges, the brilliant and bright minds were selected, and Dr. C.V. Krishnan belongs to that first batch of the training school selected by Dr. Homi Bhabha. So as a product, as a brilliant product of the first batch of the training school, he did fantastic work in chemistry, not in all branches of chemistry. Probably the most difficult is the analytical portion of chemistry. And in that, he had his great expertise, and with the deep knowledge and theoretical understanding and practical implications of analytical chemistry, he went into science education. And in United States, he made a great name for himself and institutionalized his name into the teaching of the domain of science. So he remains a role model for us to follow his footprints in the teaching methodology and pedagogy as far as science education is concerned. And we have the great authority on that subject today to inaugurate this function. I must congratulate Gopinath for choosing this title, that is, he has chosen very carefully the title Science and Technology. Now, it makes it absolutely clear to us that science is not a technology. Many of us are laboring under the illusion that science and technology are interconvertible. No, science is one thing, it asks questions and answers. Technology solves problems, is an entirely different thing. A scientific mind is a prerequisite, it's a necessary condition, but not sufficient for technology to be produced. We should understand this distinction between us. There are millions of scientists, and if you ask every scientist, he will give a definition for what science is. So you have a plethora and diversity of descriptions and definitions of science. But there is one simple definition, which Bertrand Russell gave. Science enables us to know things and do things. I repeat, science enables us to know things and to do things. Many of us do many things, we don't know anything. We know a lot of things, but we do not do it. This dichotomy between knowing and doing, there's only one way of learning, that is experiential learning. I can teach some, I can give a detailed discourse on how to climb a coconut tree to somebody. I can also give write a handbook on tree climbing. I can conduct an examination, give you 100 marks on after passing my test. But if I ask you to climb the coconut tree, and the first step you'll fall down under Newton's gravitational law. That's what will happen. So learning is something. Learning by rote is something, but learning by doing. So knowing without doing and doing without knowing are dangerous propositions. That is why experiential learning comes into absolute importance. So having said this, I would request my respected guest of honor, Dr. C.V. Krishnan, to interact with us and share his great experience in experiential learning. Thank you. Dr. Krishnan.
Thank you very much. First, I want to thank Dr. Srisan Gobinath for inviting me. And then when I saw Dr. Jayaraman, it was all the more exciting. I do not like to talk to a TV, but somehow our circumstances force us. I normally like to walk and talk,
Yes.
but there is no choice, so I had to learn to adapt. First, I want to say that I was lucky to get elected to the first batch of training school of Homi Bhabha Training School, Bar. Very lucky because I was only a BSc with chemistry, physics, and math, and there were about 10,000 interviews, and there were two of us from our college. That's because we got selected because we had a science exhibition in the college, and the questions in our interview started with our projects, and that's why we could answer the question somewhat easily. Otherwise, competing with MSc students, MSc graduates, and other things, it was not because we were intellectuals, just by chance. And I had to thank Dr. Homi Bhabha for his vision for starting the atomic energy program. I was only planning to become a upper division clerk after my BSc with 80 rupees by having a first class instead of 60 rupees for a junior clerk. So that was all of my ambition during my school and college days. But Homi Bhabha changed my life. And it is true that I became pretty good analytical chemist. And one of the first problems to solve was how to estimate free chlorine in seawater, because in Canada, in their reactor, we were using chlorine, seawater, and marine organisms were polluting and clogging the pipes. So chemical engineers put chlorine and it started corroding the pipe. So we had to answer the question, how much chlorine we had to put so that there will be minimum corrosion of the pipes and maximum destruction of the marine organisms. That is how my first research paper started. Somehow, since my time is restricted, I will say I worked for 10 years, published about 16 research papers, and we had a good time. And our lab was mostly near Dadar Cattle Road. And then I went to postdoctoral research after resigning my job and joined State University of New York. And for some strange reasons, after 3 years, when I was looking for a job, nothing was coming. Then I got this high school job teaching because and by 12 o'clock, I was free to go to the university again. So it became, I was wearing a two hat because it became intellectually challenging also. How do you make great high school teachers? And my university experience was giving me the upper hand. So I was involved in school-university partnerships. And then when I started teaching, I wanted to teach not just the high school teachers or students, but for the whole population, right from LKG through grade 12, and then undergraduates and postgraduates, and the general public. And the general public brought me to do some science magic shows. I have done about 800 science magic shows promoting science. And I know in New Delhi, the lab, they do some science shows. So that was my way of promoting science for the whole population. I also did some 16 years of Saturday science for K through 6 children and their parents. Parents sit side by side with the child and do the experiments, hands-on experiments, which is what I had been promoting in India too, in my charitable facility for 10 years, to bring all the population involved. But then I don't want just science only. So I was involved in music and arts and drawing and everything else. So that in order for the whole society to grow, we have to have the whole population in all aspects of their lives to grow in a wide way of thinking, and also to promote, to give to the society back whatever, not just what your knowledge, but also your finance. I will ask this group also to donate that. What I did was, I did not accept anything from my family or my wife's family. We both of us did not. And whatever I earned in all these 54 years, we have given it away to the society completely, because my children are also educated, and I'm happy to have that. So with that, I'm going to stop here for my 5 minutes, saying when we are promoting education, we have to also promote the aspect of giving back to the society at some point in our lives. So with that, I want to again thank you all for inviting me, and have a good time. And I hope we'll have more chance to discuss more things later on in my life. And I'm very happy to be here and present this. I declare that this session is open, which I often forget to say, and my wife always complains, I forget to say it is declared open. So I'm declaring it open, this session, for the whole community. Thank you very much again.
Thank you, Dr. Krishnan, for those glimpses and insights into your professional life, and as an inspiration for us to follow. Thank you very much for sharing those details. Now we get into the nitty-gritty of the subject. We have with us Prateta Malik. He is a graduate in physics from the University of New Hampshire, and he did this in 2005. And within 4 years, he secured his PhD. You know, the distance between your BS and PhD and the age at which you get PhD, that is a barometer of professional excellence. Where do you get it from? At what age you got it? In ancient Greece, the age of a woman is considered only after her marriage. That was a traditional Greek system. So in academics, the age at PhD, was it at 25? Was it at 27? Was it at 35? That makes a qualitative and quantitative difference in academic trajectories. So here we have Prateta Malik. In 4 years, he secured his PhD from, and that in astronomy, one of the most complex, intriguing topics, and where, you know, there are more concepts and conflicting concepts. We are all aware of the great conflict which Nadlikar had with Eddington and so on. Lots of theories and lots of experimental evidence. So we would definitely like to hear from him when there is a large magnitude of theories and concepts around, and there are a few experimental data, marrying that data with the theories. That is where you have a large problem. And the contemporary experimental evidence-based reasoning, which science is brought from experimental empirical data, is best seen in astronomy. So let's begin, and I invite Prateta to start and to flag off our discussion on this.
Hello, good evening. Thank you for
Prateta, thank you.
Good evening, good evening. Dr. Krishnan, Dr. Jayaraman, thank you so much. Dr. Gopinath, for the invitation and introductions. Very pleased to have so many of you here, Dr. Mahajan as well as distinguished teachers, HODs. I'm sure lots of people from various sections of the educational field, in schools, in institutions, in research institutes. We're very happy to be here. Our organization, in comparison, is a small one. We started about 4.5 years back as a startup social enterprise to take hands-on science learning to as many children and teachers as possible in India. And now things are happening where we are also able to go with the same things abroad. In that sense, the pandemic has helped a little bit because it has definitely cut down boundaries. So we're able to have meetings like this, which probably a couple of years ago would not have happened and would have been restricted to a smaller audience in a face-to-face kind of setting. So we have to take whatever straws we can clutch at what's been a very tough time, I think, globally for lots of people, especially in the education field and in India for children who've been at home for the better part of 2 years, missing out on a lot of activities and social fun that they can have at school. What ThinkTac has done over the last 4 years, as well as with our partner NGO Innovation and Science Promotion Foundation, is we've been able to reach out to large sections of the population, both before the pandemic and after, trying to take as many simple hands-on activities into the classroom or in children's homes as possible. We try to align that with the curriculum. So we have curated more than 500 activities over the years, inspired by initially by folks like Arvind Gupta and so on, who had a large body of work using simple materials, recyclable materials, raw materials, to create as many interesting activities in physics, chemistry, and biology as possible. And we have a very even spread among these 3 subjects, and all our annual programs and etc. that we have for each of the grades, for each of the syllabuses that are taught in India, have a good mixture of all the 3 science subjects. We're also delving a little bit into maths and creating maths activities as well for starting with senior school children and then moving on to the younger children as well. Just to give a little bit background about the name, ThinkTac, you must be wondering where that's come from. So think is because we want children and teachers, of course, to use their head and think. Tac is a substring of the word tactile. So we make activities and models, etc., which each child can make with their own hands with simple materials that they take back home with them. So it's not, in that sense, it's not a traditional lab experiment where you go to a lab, do an experiment and come out. You actually make the equipment, study it, make observations, play around with it, and then take that back home to explore more and tinker further and so on. The simple materials allow children to also have a lot of scope for tinkering, exploration, breaking, remaking, and without the fear of, losing some expensive equipment or something like that. So just to give you a quick introduction of the kind of things that we have, people may be familiar with, because this was a kind of a toy that people used to, especially in the previous generation when we were kids, or maybe even some of you were, used to get this kind of toffee wrapper thing in your in some candies that you bought, and you could tie a string at either end to this. In this case, I've used a thin cardboard piece. There's a button in the middle, and I've tied 2 strings through those button holes. What I can do with this is I can wind it a little bit, and then I can start spinning it like this. And as the speed builds up, I'm able to spin it very fast. You may be able to even hear the whirring sound. Right? So this thing is spinning very fast. We've used strobe lights to actually measure the speed of how fast this rotates. And it goes up to 3000 RPM. So about 50 to 60 times a second is how fast this rotates. What you can do with that is you can tape a small vial of any kind of colloid. So typically, say, even blood or very muddy, fine muddy water. And you can put it here, the mud that doesn't settle in the water. You do this pulling and pushing for a couple of minutes, and you separate the 2. And you have a very simple model of a centrifuge. Shows you how easily you can separate some pretty complex colloids with that. If you're brave enough to take a little bit of your blood and do it in one of those 0.1 ml vials, you can try that, and you can actually see the separation, which takes a little bit more time when you do it with a finer colloid like blood. So that's one of very popular experiment. You can also extend it to a physics experiment by, say, putting a color wheel and seeing how the colors mix, or even talk about rotation if you want. Another very popular one of our activities is this, where we just take a small glass bead and place it on an ice cream stick and put some foam to keep it in place. At the back, I have a slide. In this case, it's a stained slide of an onion peel. And I just need to look through the bead, and I'm able to see the cells. Okay, we have lots of resources online where you can actually see the pictures of these cells, and maybe my colleague may share some with you later. But I was just showing you how simple it is to make and play with a single glass bead. You get to see cells on an onion peel, and you have varying sizes of these glass beads. As you go smaller, you get more magnification and you can see things more clearly, but in a sense, it's also tougher to see because the focus and so on becomes more and more sensitive as you go to smaller and smaller lenses. So this is very popular, one of our biology activities where we not only see onion peels, but also things like pollen, the cross-section of a plant stem, leaf stomata, various fungi and various other specimens, which are very, very enjoyable to see through pocket microscope like this, which I think every child should have in her or his pocket, carrying around and exploring nature and exploring the microscopic world around them. Similarly, when we play with gadgets, we always wonder how they are made. We all have phones. I'm speaking through something which happens to be a microphone, and it's getting the sound and is getting converted to electrical energy, and all complicated stuff happening in a kind of black box, which we don't get to see. So when I was told that, oh, you can make a speaker yourself with very simple materials, I was quite taken aback. And this is one of our, again, popular activities, maybe one for the senior classes, because we're studying a little bit of electromagnetism and changing forms of energy and so on. And also because it requires a little bit more of dexterity in making. So in this particular activity, inside this plastic container, I have not only a magnet, a neodymium magnet that's stuck on this plastic cap, but also I've wound about 200 turns of very thin copper wire, insulated copper wire, around this cardboard tube kind of thing, so that the magnet can sit within that. And then I've connected the two ends of that, of the copper wire to an audio jack, any one that you can just cut one end, the two wires that come out, you connect the two ends of that, of the copper wire, and I can now plug this into any audio device, put this on my ear, and actually hear the same music or the same voice that I would from a professional speaker that's in the phone. So here I've made my own speaker with very simple materials, and I know exactly how it works and how the signals are getting exchanged, how the magnet is vibrating, which is then vibrating a membrane, and I'm able to actually hear things straight from any kind of audio device. So these are the kind of activities we make with children, simple activities. Starting, we have programs from grade 1 to 10. We got this opportunity because recently our 9th and 10th alternate lab program, series of 33 experiments for 9th and 10th standard has been approved by CBSE. And so I think some of you may be aware of that, which is why we were invited here to talk a little bit about that and how children sitting at home can continue to do a lot of science with simple materials sitting at home without the requirement for fancy lab equipment and things like that. And it's a great honor for us that we've been invited here. Also, that the partnership with CBSE has taken it such that they've approved our content and said that children can do this as their 9th and 10th lab experiments instead of the ones that are prescribed officially, which they have to do inside a physical lab. So that's all I'll say for now. And I think Vishal has a nice presentation set up for you, where he'll talk about a lot of the our pedagogy and our implementation, how to contact us, etc. So the whole picture. I just gave you a brief introduction. And Vishal, you want to take over?
Yes, Vishal, please join us. We know that you are from IIT and you are deeply immersed in the information technology sector, both with the MS from IIT and has been in the industry with hands-on experience of the nuances of the industry. And we would like to know how you would like to share your experience for building the science capital of the schools.
Thank you, Dr. Jairam. Am I audible?
Yes, yes.
Yes.
Thank you. What I was planning to share today is the importance of learning through experience. There was a good context set by Dr. Jairam, Dr. Krishnan. I thought of focusing on the practical aspect of how do you actually take it inside the classroom. And the reason that becomes important is a school operates in a structured manner, and it's important that a program like this plugs in to the structure without disturbing it much. I want to take help of few slides and take an overview. So let me share my screen and present. Dr. Jairam, my screen is visible?
No, not to me. Yes. Vishal, not to me. Screen sharing
Started
started.
sharing, sir.
It started
Yes,
sharing.
it's
Now
coming,
it's visible. Now it's visible.
Absolutely visible.
Okay. Yeah, thank you, sir. Okay. Okay, so before we proceed further, so if we are talking about an experiential program and that too in science, let's just think through a little and if possible also answer on the chat window, what in your opinion should be the features of a program like this. And please note that I'm emphasizing on having a program because experience is just one part of experiential learning. And once you share some of your thoughts, then I'll enlist some of the features which I've thought of. So many of these things are driven by the opinion that we have and which is driven by the experience we have had during the last 7 years of working with children and teachers. The reason raising questions before coming to a point becomes important is that way we are more prepared for the points which follow. So let me ask more specific question now. Probably it was slightly more open-ended. So now let me list down some specific features, and what you can share is if you had to pick. So as you can see, it's a nice hexagon with 6 bullet points. And the question that I have is, if you had to pick only 3 out of this, which are your top 3 priorities, and which ones would those be? Let me clarify what I mean by some of these points, because different words may mean differently to different people. So scientific approach. So let's say the objective I have through this program, the objective I would like to achieve is the children, the students, they get to practice scientific approach so that it becomes a habit for them. Second is get them excited about science, because at least I personally feel science is extremely fascinating, extremely exciting and fun. Sometimes we see around that interest level goes down for some of the students. How important you think is the connection to curriculum? So what if an experiential program runs as a parallel track? Is it important to also arrive at the concepts, connect the experiences to the concepts, or it's sufficient to have an experience which is fun, engaging, which triggers questions and leave the questions unanswered? When I use the word reach, I'm not talking only about reaching out to all socioeconomic backgrounds. So of course that's equally important, because personally I believe that scientific exploration is the fundamental right of any child, irrespective of what kind of background the child has. But here I'm also talking about the reach in terms of the different age groups.
Vishal, we are still on the initial screen. Have you moved forward?
I have.
Yeah.
I've already moved to the second slide.
Yeah. So we are able to view still only the first slide.
That is a little surprising. Okay, just 1 minute. Let me stop sharing and share again. Good that you pointed out, Prashita. Yes, now let me
This is
see
now
if
visible. Yeah.
yeah.
Yeah, now we can see the hexagons.
You're muted. You're muted, Mr. Malik.
Yeah, yeah. Can you hear me now?
Yeah, yes.
Yes, yes.
Yeah. So I was saying when I'm talking about reach, I'm also talking about the grades. So what's your belief? Do you think the younger grades should also be engaged in an experiential program, or should it actually start at, let's say, the grade 9, 10, 11, 12, etc.? And younger grades, what? So should it be grade 1, kindergarten? At what stage should the children start getting involved? And how important is the cost factor when we talk about the design of an experiential learning program? So as we continue to talk about this, please keep sharing your thoughts on the chat window because that helps. So as Prashita was saying, the virtual medium is amazing. It allows us to reach out, but it also loses on the face-to-face connect, what Dr. Krishnan was probably referring to. That, but if we keep sharing our thoughts, communicating through these means like the chat window, it helps us understand each other. So Anuradha ma'am is saying right from kindergarten, right from pre-primary. That's interesting. Okay, let's see. And what range should the cost of implementing such a program be? And note that I'm asking these questions more to set the background in terms of if we want to start thinking about implementing it inside the school structure, what kind of program we should have. Now, having said all this, is it that we don't have any options? Is it that okay, now luckily as I'm moving the slide, I can see that you all are also able to see it. So what are the existing options? And again, as I said, I'm only listing down some. I'm sure there are more, and this is some kind of categorization. And this time I have a pentagon instead of a hexagon. So we have the conventional laboratories, which many of us would have experienced. As in my case, it was from grade 10 onwards. And these days, we also have lots of maker spaces kind of places coming up. The Atal Tinkering Lab is one of the examples. Then we also have these different kits, especially artificial intelligence and robotics kind of kits, or even science-related kits, which are very quickly ready to assemble, packaged in factory manufactured plug-and-play kind of setups. So that's another way to implement. We also hear about exploratorium or science centers or museums. So museums have always been there. In Bangalore itself, we have some really fascinating. So Vishweshwara Museum, each time I go, it's just one section of the museum that I end up visiting and not even going to the next section. That's the extent of exciting things we have. And so is museum or science center the answer? We also have lots of competitions and happening these days, and many schools make the children exhibit, come up with their own ideas and models and exhibit them typically at the end of the year. And when we talk about competitions, in fact, we ourselves host this competition, which is a national level free competition called the Raman Awards in association with the Raman Research Institute Trust. So which of these, let's say if hopefully this captures most of the options for implementing an experiential program. So what do you think, which of these would be your favorite? And obviously I'm asking for your favorite. There's no right answer for this. And this is, so in some sense, what I'm attempting to do is, in fact, I'm reminded of this thing. If you approach any topic as a research topic, it was very interesting for me to learn when I first noticed it, that you first publish a survey paper, which is like take an overview, look at what all work has already been done, and share. And after that, you start going deeper, because that helps you defining the problem. And that's what I'm attempting to do in a very quick 10-15 minutes discussion. And here the pros and cons of each of these 5 models which we just saw. This again is our opinion. It could be different for, and in fact, the same model being implemented by different people may have a different effect. I'm using some kind of color coding to communicate my thoughts. So conventional laboratories, scientific approach, because we are made to write a manual, which of course has some of the very standard kind of structure where you write the aim and apparatus and the procedure. As a student, when I had followed that, it was fun, but it was also monotonous, and I never understood, if I've done something already, why should I write what I did? And of course, I can see it has some value because it reinforces the process in your head. But I think scientific approach is much more than that. But I would still like to give put a green post-it when it comes to scientific approach getting developed, or at least children getting exposed to this approach. What about the curriculum connection? That also, so obviously experiential program cannot have 100% coverage. Practically, it's extremely difficult. Typically, experiential program would like to address some of the topics which are difficult to visualize and which will excite the students. But reasonably good curriculum connect. What about the interest that it triggers? As a student, when I went through this experience, it was exciting, but not all the time. There were many experiments where it wasn't so much fun to go through them. Conceptual clarity, yes, it depends. Sometimes our teachers used to fail to connect, and there's nothing in the structure itself, in the process itself, which can ensure that what you experience gets connected to the concepts. In terms of reach, it's most of the schools, it's from grade 9 onwards, so the younger grades. And it was interesting to see that many of you felt that we should be starting the experience part early enough. Also, the reach, because of the cost, reach is further impacted. There are so many schools, especially in India, where we are talking about even setting up a toilet. So the question of having a laboratory with sophisticated instruments is unlikely. And in fact, some of the government schools that we have worked with, we had very nice laboratories, but they were locked. And the key used to stay with the headmaster because it has instruments which everyone was worried that such a big corporate has donated for this, so we should better keep it safe. So it's sitting there nicely, safely, occupying one room. Let us look at some of the other options. So tinkering labs, yes, it can get you excited, but what about other aspects? Especially the, also probably because the tinkering lab concept is getting developed, it's still in the initial stage. So not many people have built a program around it. in most of the schools where I've seen the ATLs which have been set up, I've seen that focus stays on the 3D printer and machines like that. And of course, Arduino board or some of these are interesting latest equipment which children should have the exposure to, but does it connect to the curriculum? What about taking the experience to the concepts? And also, how many children can you reach through this? Kits, usually people do a good curriculum connection because they have to sell it as well, right? The schools should be ready to buy them. So without them making a curriculum connection, I've usually seen the companies who manufacture the kits, they do a reasonably good job there. In terms of triggering interest, not sure, because also because it's ready to assemble. So it also silently gives a message that I cannot explore science unless such and such organization comes and gives me these kits which I can assemble and then start playing around with. Whereas the fact is that science is all around us. It's part of our life. And yes, reach is extremely limited because only wherever these companies are able to reach, wherever the schools agree to buy, it's only those children who will get benefited out of it. Science centers, as I said, extremely exciting and hence good in triggering interest, but many other aspects because there isn't a program around it. So the Vishwesharaya Museum, the simple machines related section, there itself I've spent the entire day. But I wish I could do more than just pressing that one button. So each time I press the button, something happens, but what happens is always the same thing. So my exploration gets limited to that single result. Do I get an opportunity to explore scientifically through that kind of method? And of course, many of the exhibits there, they cover some of the advanced concepts, and hence if it has to be made a part of a school curriculum, we need to do a lot of work. Exhibitions and competitions, yes, scientific approach, you get to practice, and also a little bit of conceptual clarity will be arrived at, especially for the students who exhibit it themselves. But how many students will participate in this? And most of the times it's those students who are excited about science, they would take part in this, and hence you get to reach to a limited audience. Now, let me extend the demonstrations which Rachita was making, and show a few more, and then talk about the model that we have, the think tank model. Rachita, just confirm if my screen has, so my
Stop
video
sharing.
is clearly visible? Yeah. Okay.
Stop sharing, yeah.
Yeah, thanks. Okay, so I'll start with something very simple. So I have a couple of magnets in my hand. Again, many children are fascinated about it. And the first thing which we talk about is the two poles and attraction and repulsion. If I look at a ring magnet, and I've deliberately chosen a ring magnet because a bar magnet, typically we tend to assume, thanks to those magnetic field lines which are drawn in the textbook, that the North Pole is here and South Pole, which by the way is not true for every magnet which is cuboid shaped, right? But in a ring magnet, where are the poles? Is it on the top and bottom? Is it like inside ring and outside ring, or the faces? And let's do a little bit of playing around for that. So as you can see, the bottom magnet has got stuck to the top one. Now, if I take the bottom magnet, flip it, and then try to connect to the same point. So remember, this point and this point of both the magnets, they both are same. So here it's getting stuck. But now if I flip it, then I'm not able to connect them. Now they are repelling. And of course, you don't have it in your hands, so you cannot feel the repulsion which I'm feeling here. But it starts repelling as soon as I flip the bottom magnet. And what does that tell us? Based on this, can I infer the poles, the location of the magnetic poles of the ring magnet? And I would leave you with that question, and of course we'll come back to that, but let me show you one of the applications, one of the models that we make out of this. So what I have here with me is a cycle spoke, which has been bent in a certain way so that you make a light pole kind of shape. And this, by the way, can be bent with the hand, bare hand, with little power. And what I'm going to do is, I have this one of the old CDs, and I'll stick this light pole shaped stand, which I've made using the magnet, on the CD. So I've stuck it on the CD. I'm taking a pen which has a magnet, one of the ring magnets. Thanks to the ring, I can insert the magnet through this. Now, this itself being an alloy of iron, it is magnetic in nature. So I can stick a couple of ring magnets on the cycle spoke itself. And the way they have been fixed is these magnets, they attract the magnet which has been fixed on the pen. Now what I'll do is, I'll place the pen on its tip, and as you can see, there is significant space between the magnets, and the pen is able to stand on its tip. And not just that, I can do a few more things. I can take a paper, just a thick paper, and cut the four corners. And here, the four corners, they have been bent in a way so that I can give it the shape of a turbine. So as you can see, all the four corners, a flap is lifted. So what I'll do is, I've fixed a tape at the bottom of this fan. I'm fixing it on top of the pen, and now I can blow this from the top. What's the advantage of doing this? Now I can start experimenting and recording some observations around this. So let's say I change the surface. Instead of CD, I take a cardboard, or I take a piece of cloth, and each time I'm going to take a deep breath and do one deep exhale, so that the amount of air, and from the same angle, if I do that, then I'm ensuring that all the other variables have the same value. What I'm changing is only the value of a single variable, which is the base. And through that, I can explore what are the what's the impact on the coefficient of friction of the surface of the base which I'm using. Another experiment I can do is, I can place the pen at different angles and measure the angle at which, the tilt at which the pen is able to stand on its tip. Since we are playing with magnets, permanent magnets in real life, they are not used as often because you cannot control the strength of those magnets. What's used most often is to pass current through a conductor and convert it to an electromagnet. Here is another example of that. So I have a pencil cell, a AA cell, and two safety pins have been fixed using a wide rubber band. I place a few magnets here, and here I have a copper wire, so a coil made through copper wire, copper which is not a magnetic material, but as soon as I insert it in the loops of this safety pin, current starts passing through the copper wire, and that makes it a magnet. And as soon as I give it a little push, just 1 second. And thanks to the protruding side of the AA cell, sometimes the connectivity is an issue. And once it starts rotating, this acts as a, so this is a simple model of a motor. So just 1 minute. Let me do a little bit of repair. where it gets very interesting is to start observing and recording the direction in which the coil rotates and see if you can control the direction. And so you end up deriving the Fleming's left-hand rule, because you know the direction in which current is flowing, you know the direction in which magnetic field exists, and based on that, if you can predict the direction in which the coil will get the force. And this design, the particular design, there is something built in the design of the motor itself. So as you can see now, the coil is rotating, and exact opposite of the motor. Just 1 second. This is slightly tricky, and that's where sometimes these simple looking models, they become even more interesting, because when you go through the process of troubleshooting, you end up figuring out many things. So this coil, very simple looking coil, it is enameled copper wire, and the insulation has to be scraped in a certain manner, so to make the current to pass through. But one of the terminals, you retain the insulation so that the circuit keeps breaking. I'll not go into the details right now, because otherwise we'll end up looking at only a single model. Just the opposite of a motor, so I have a 5 ml syringe with a magnet inside and around 800 to 1000 turns of copper wire. And as I shake the syringe, the magnet inside moves and cuts the, so as the magnetic field gets cut, the current gets produced. So that was induction, and majority of the electricity which we receive at home, other than of course what comes through the battery, that comes through this very simple mechanism. And since we are talking about batteries, let me show a very simple design of a battery. So I have copper strip with me, a magnesium strip, and this model I'll make right here in front of you. So I've taken a filter paper, cut the filter paper into half, and I'm going to wrap the filter paper around the magnesium strip. And one would, of course, raise a question that why a filter paper, and can I use something else? Let's come back to that. Now I'll take the copper strip and wrap the copper strip around the magnesium strip which I've just made. And what I have made by doing this is a magnesium copper cell. I've kept another magnesium copper cell ready with me, because to light a red LED, I require 2 cells. So I'll connect these 2 cells in series to make a 2-cell battery. I'm folding this so that the other terminal of the LED can touch the copper. So as you can see, the LED is still not lit, because what is separating the 2 conductors is only air. And once I put something which is a good conductor of electricity in this, we may see something interesting. So I have some vinegar in this bottle. I'll put a few drops of vinegar on one side. So I've wet some part of one cell, and here I'm wetting the second cell as well. And just give me a minute. Sometimes and as you can see, as soon as I resolve the connectivity issue, the battery is lit. And this kind of a battery made in such a simple manner, this continues to power this small LED till the water in the vinegar that evaporates, which typically in a Bangalore kind of setup, we have seen it takes around 48 hours. After that, you add plain water to this and it starts to light again. What all can I use as the electrolyte? So usually what we provide to children is an observation sheet where they record what happens when I add vinegar, and half of the classroom records what happens when they add sodium bicarbonate solution. And before they observe and record this, they make a prediction of what would happen. And of course, any acid or any base is a good conductor of electricity when it comes to liquid, because they have freely moving ions. Now we are talking about acids and bases. Here is another simple one, which at least in India can be done in any household, which is what we had done when the pandemic came last year. So in 2019, when we had strict lockdown, we were forced to use all the material which was available only at home. So here I have some turmeric, and what you are seeing here in my hand is a custom made test tube stand, a foam piece with 3 test tubes bound using binding wire. And of course, the idea behind some of these hacks is to give a silent message to the students who work on this, that you don't necessarily depend on sophisticated equipment. What I've done is added turmeric to plain water, and the color is still yellow. Ignore the color of the solution in these 2 test tubes for now. I'll come back to what it is about. Turmeric solution, if you add something which is alkaline, and I'm saying the word alkaline because not necessarily. So if I add something which is alkaline, that changes the color to red. If I add something which is acidic, the color remains unchanged. And let's experience that right now. So I have a base in this, happens to be a slightly concentrated base, and there's a reason I'm using a concentrated base, because I'll come back to that. So I've added some sodium hydroxide here, and this is how turmeric can act as a base indicator. But what about acids? Because as we said, when you add acid, the color remains unchanged. Let me pick the vinegar bottle and add it back to this and see if the color changes back to yellow. So the top part where I've added vinegar, as you can see, the color has changed back to yellow. And that's how a combination of turmeric and a base and turmeric solution that you prepare, a combination of these 2 can work as an acid-base indicator. And the reason I used sodium hydroxide earlier, which is a much stronger base, is to make a point that even a stronger base, if the neutralization you are able to manage, then something like vinegar is able to change the color. It's said that traditionally vermilion, which is also called as kumkum or sindoor in many parts of India, that used to be manufactured by using chuna, that is lime powder, that used to be mixed with turmeric, and that's how you would make vermilion. So it's vermilion which acts as an acid indicator, and turmeric which acts as a base indicator. So here I have prepared another solution where I've added tuna, that is which is calcium oxide, added to water, that becomes calcium hydroxide, and the color changes to a nice maroonish red. And I've taken a couple of samples of that in these other 2 test tubes. And what we will now do is something very interesting with this. I've take a plastic straw, blow in one of these, and see if the exhaled air can help me change the color. And of course, I'm doing this live. You'll have to be patient, but please keep counting the breaths which I'm blowing into this. So that is 1 breath, and note that I'm not doing a deep exhale. And I'll continue to count the number of breaths I require to change the color. And with 7 breaths, I could, and this I've kept as a reference, which was taken from the same set. So in 7 breaths, I could neutralize this and change the color. And that's where this becomes very interesting, because now I can use just turmeric and any base, which could have been detergent. In this case, I've used tuna. You use a base, change the color to a vermilion color. Using the exhaled air, change the color, count the number of breaths. And that's an indicator of the rate at which our body respires. So the metabolic rate also gets indicated. So the observation worksheets that we provide to children, they do a quick exercise, come back and check the number of breaths they require to neutralize the same concentration of calcium hydroxide. Something else increases as we exercise, And how do they measure that? They make their own stethoscope using plastic pipe, wire, and here we attach a balloon. So I've deliberately cut one part of the balloon so that you can clearly see. And here it's just a wide bottle cap through which we insert the plastic pipe, and the balloon acts as a diaphragm. So the children record the change in heartbeat, change in the respiration rate, and we also have them measure the lung capacity. And this is how the circulatory and respiratory system, it connects back very neatly. Let me do a quick time check. And Prachita, is there anything in the chat window which we need to respond to, which I should pause for?
Not really. People just praising your the activities and all that they're seeing. So a lot of interesting and amazing and so on.
Sure. I'll probably take a pause and we'll come back to the analysis that we were doing in the beginning. Let me show one more, because this one I want to also go a little deeper and talk about the process which we follow, because as I said, what's valuable is not just the experience part, but the program which gets built around it. What else you do with these activities. And this one I'm deliberately picking a pretty simple one, where the material is very simple. So I have a fat straw and another straw which is a smaller diameter. And this straw, I'm going to fold it approximately in the middle, and these two corners, I'll cut it out. And here is an interesting question, that when I open this straw, what shape will I see? Given that we are a large audience, it will be difficult for us to interact, but that would have been fun. Usually with children, we go through that process. When I open this, what shape will I get? And note that what I've cut is one piece, which is a triangular piece from the two corners. And I'm assuming that at least you have thought, if not written on the chat window. Let me open, and you see a diamond shaped hole. What's very interesting is this quadrilateral that you see on both the sides, that is guaranteed to be a rhombus each time. And why is that the case? So is it just another quadrilateral with parallel sides, or always a rhombus? And I'm claiming that it will always be a rhombus. And why would that be the case? I've cut the straw on both the sides. On each side, I've cut the straw at 4 different places, but the number of times I use the scissor on one side is just once. So a single cut has led to all the 4 cuts. And hence, irrespective of which way I cut, I'll always end up cutting the straw at the 4 places in equal lengths. Now, what I'm doing is I'm pressing the straw at the 2 ends and closing the opening of the straw using a tape so that no air can escape. But we are not happy with blocking the air fully, so we will open it a little. So one corner I have cut. I'll cut the other corner, which is the diagonally opposite corner. And I'm ready to play with this. So let me repeat this. So this corner is cut, this corner is cut. So if air enters from these 2 holes, it will exit from this and this corner. Now, how will the air enter? So I'll now take the second straw, and this straw at one end, I've made one hole, just a single hole, which is close to the end of this green straw. So I'll insert this end, which has a hole in the diamond shaped hole, and block the air from coming out. And as I blow through, the air enters the red straw, exits from the 2 corners, and it starts rotating. And which direction is it rotating? Let's observe. This time I blew slowly so that you can observe. You can type in the chat window, is it clockwise, anti-clockwise, and clockwise or anti-clockwise from my point of view, because it could be reversed. So as I see from here, it is rotating in this direction. Now what do I do to make it rotate in the opposite direction? And that's where it gives, yes, it is rotating clockwise. And what do I do to make it rotate anti-clockwise? And quite often children say that you start taking the air in now, which of course will not do much. Yes, suck. I see that one of you also said exactly that, but nothing happens when I do that. Sometimes people say that, okay, point this hole in the direction. So if I was pointing in this direction, now I'll point it in the opposite direction. But it will continue to rotate in the same direction. Is there a correlation between the holes at the diagonal and the direction in which it rotates? So if I have the hole on the right upper corner, is the straw getting pushed down on the right side? Here I have on the left bottom corner. So is it getting pushed up here or is it getting pushed down? And if that's the case, if that gives you an intuition, when I flip it, now the air exits from here. Will it rotate in this direction or this direction? So is the direction of rotation same as the direction in which air comes out, or is it opposite? As you can see, we have managed to make it rotate anti-clockwise. If that's the case, what will happen if I cut all the four corners? As the straw, I'm not worried about breaking a sophisticated instrument, so I can play around. I can just go and cut. So now I have cut both the corners here, and I'll cut the second corner as well. And going by the theory, which is, let's state the theory, as the air exits, it takes the support of the straw and pushes the straw in the opposite direction, which means every action has equal and opposite reactions. Quite often I see children as well as teachers getting confused there, that action and reaction, if they are equal and opposite, why don't they cancel each other? But they are on different objects. So the air, so if a ball hits the bat, action is on the bat, then reaction is on the ball. Action, reaction. So here also action and reaction. So then they both should cancel. In this case, there are two actions which are in opposite direction. So I would predict, which is what we had predicted when we did this first time, that it would not rotate. As you can see, there is a little bit of torque, and if I give a little push with my fingers, it's also moving further. So how is that happening? Of course, it also depends on the size of the hole. Instead of cutting the corners, if I cut at an intermediate position, will that also rotate? So here the corners are intact, but I've made a cut here, I've made a cut here. Will this rotate? That also works. If I take a longer straw and don't make the hole in the center, what will happen in that case? And as you can see, these are only some 4 or 5 variations. So I've been changing 1 or 2 variables at a time, and only 4 or 5 variations of the propeller, as we say, which I just demonstrated. In our teacher training, sometimes we go on with just this one experiment for literally for 3 hours, and we still end up with unanswered questions. Let's say instead of air, if I blow water, what will happen? Will it rotate? And as soon as you change one variable, quite often you end up moving to another concept, the one which is not at the center. So now we have not stayed only at action reaction. The moment I bring in water, I'm not talking only about Newton's laws. I'm also talking about the impact of density, etc. So let me now sum this up and conclude. So I'll take help of the slides and just show another couple of slides, and then we can open for Q&A. Is my screen visible? Yeah, I can see it. So what we have learned based on the experiments we have done, and here I'm talking about experiments in terms of working with the schools and children, which is a wide range, different geographies and different economic backgrounds. What we have learned is experience is just the beginning, and even with the concrete experience, it helps to have a certain kind of design in place, which I'll come back to. But experience is just one of the 4 stages. It's equally important to make the students reflect back on what they observed, pay attention to many aspects, and quite often you need to draw their attention before conducting the experiment, which happens through in some cases the prediction questions that we ask. Sometimes we ask them to hypothesize upfront before they conduct the experiment, and all that happens through these what we call as the observation worksheet. And it's equally important that after they have experimented, recorded their observations, you close the loop by actually talking about the concepts. And this is where some of the formative assessment questions that we have been preparing, they come handy and help the teacher in connecting the dots. And as we just saw, the mind actually starts opening up when you start playing around further. And if the design is a black box, then it's very difficult to start playing around. When it is open with most of the times it's simple material which is used, that helps in allowing the exploration to happen naturally. All of these experiments, as Prachita was saying, we have around 500 of them in science as of now, which we have mapped to the curriculum for the different boards, which includes CBSE, ICSE, Cambridge board as well. And this is just a sample, one example of the mapping to CBSE 5 activities from the 7th grade. And it's important that in terms of a conventional sense, is it also aiding the teachers in covering part of the syllabus? And that's the reason we have put the percentage coverage also. In terms of reach, what has been a biggest blessing and help for us is there are some of these big partners who have been prescribing these activities. As Prachita was saying in the beginning, our program for the 9th and 10th grade has been reviewed and approved by CBSE and recommended as an alternate lab, which one can conduct with children sitting at their home. So pandemic or without pandemic, it can work. Oxford University Press on their Oxford Advantage platform from grade 3 to 8, each grade there are 5 activities which have been made a part of the platform. And as I said, we have also been partnering with the Raman Research Institute Trust and IIT Gandhinagar. And what also helps us increase the reach in terms of reaching out and working with the younger grades as well as children from different backgrounds is the fact that most of the material is also low cost and it is simple, which leads to exploration, natural exploration. And we work from grade 1 to 10. That is all I had. I think my colleague Raghu would like to address you further. So Dr. Jairam, if that is okay, then Raghu had a few things to share, just a couple of minutes.
Yes, let us invite Raghu. Yes, please, Raghu, come in. We are eagerly looking forward to your exposition. Yes.
Is he there? Is Raghu?
Raghu?
Yeah, I just saw him putting a message on the chat window. Raghu, just check if you are speaking on mute.
Meanwhile,
He had some technical issues with his laptop. So I don't know, he's logged in from his phone. We have to see if he is able to unmute himself. You can make him co-host, he should be able to.
He was the co-host. Let me see.
Yeah, but he dropped off multiple times. Yeah.
Yeah, now I'm able to hear.
Okay. Yeah.
Please, sir.
Okay, so like I had posted in the chat group, I'm glad that many of you are asking questions about how to implement those kind of things. So we'll definitely take it forward. You can fill your expression of interest in the Google Sheet I shared. And you can also write to me in case that you have any problem in accessing the Google Sheet. You can write to me as well, raghu.ap@thinktac.com. So
There seems
then
to
we
be
will
an
get
access
back to you.
issue, Raghu.
Oh, there is access issue, is it? Okay, then.
Sir,
Yeah,
please share your number. I think that is the best thing now.
Okay, okay.
So they
I'll
can
share-
directly contact you. Then
Okay,
if you may share this in WhatsApp or something like that.
Okay, sure. I'll share my number.
Yes, sir. So meanwhile, we can ask for questions. We have hardly 9 minutes left. I'm only worried about the part. Jaravan, sir.
Yes.
Yeah, meanwhile, people can type their questions, or if you just show that what is it, virtual hand, we will unmute you. There are a lot of science teachers are there. Vijayalakshmi ma'am, she is also a physics teacher. A lot of science teachers are there, and a lot of good feedbacks also with these little experiments. Yeah, you can just note down Mr. Raghu's number there.
I've also pasted the link to the form. This one should work.
Okay. Yeah, we can use both. Now you have the contact number and the form. Please make use of both the things. It's need of today's world. So again, that is also cannot open. I really don't know what is the problem with this Google Forms nowadays. And meanwhile, teachers, if you have any doubts, these two resource people are there. You can just raise your hand. We have 8 minutes more time. Then we can wind up the session at 6 o'clock sharp.
I see that some teachers are able to access it. Gopinath sir. So
then
Gulshan sir have just said.
Anyway, yeah. Very good, very good. I'm sorry.
Yeah, the only requirement seems to be you need to sign into a Google account, but if you do that, then you should be able to access this.
Yeah, I think somebody has submitted as well. So yeah, this one is working.
Okay. Yeah, sir, there is a question coming in the chat box, I believe. It's about nursery classes. Jaravan sir, can I read it?
Please.
In
Please go ahead.
nursery classes and kindergarten classes, having a science corner does help in experiential learning. Do you have training session for such teachers?
Yes, we have done. Only thing I would like to clarify there is when we work with the teachers of the younger grades, especially this age group, then the focus is more on giving the experience to the children and not so much about ensuring that the concept gets covered. So in the curriculum, let's say the Bernoulli's principle would probably show up at grade 11, but that doesn't mean in real life Bernoulli doesn't show up. So to this grade, giving them the experience is a lot more important. But yes, we do work with the kindergarten children and teachers as well. Those are much simpler material and a lot of fun kind of activities.
I think questions are not coming up. Then in meanwhile, let me also tell you the next second Saturday. The next Saturday, CAR is coming with another series. Now 4 Saturdays we have 4 series. The first Saturday, Science and Technology. The second Saturday, the school solutions. This is actually, we'll discuss the current issues which we are facing. And this will happen every second Saturday. And third Saturday, we will discuss more on to the, what do you call, the government, the CBSE projects like decoding Nipun Bharat, all that. And of course, fourth Saturday is our, what is that? Best practices of schools. So that is the way we have divided. One more humble request to all the educators here. Every day we used to have a mindfulness session conducted by Krishna. He is doing a mindful session every day, 7:30 to 7:45. Sunday we extend this to 15 minutes more, 7:30 to 8. So please make use of this, and the same, the link which you have access today can be used for this session also. Sunday 30 minutes, the other days only 15 minutes. Please do attend that. We're getting a lot of excellent feedback from our teachers. I think Mr. Pavan has raised. Sir, you can ask question, I believe is a question. Mr. Pavan?
Yes.
Yeah,
Thank you
please.
so much. Hello, can you hear me?
Yes, sir. Yes, sir.
Yeah. So amazing session, and thanks, Vishal. Had the privilege of meeting up Vishal many years ago in Pune.
Oh,
And so hi, this is Pavan from DLRC. Vishal, this is as always really inspiring, and thanks to CAR to really organize this, really invigorating session. Which schools have really been able to absorb the exciting things that you shared across and followed processes? Is there like a success story, that a few success stories that you can mention, so that we can celebrate those and also take inspiration from those? That'll be great if you can mention a few of those. And my other question is actually that what is the danger of doing? Is there any concern that we all should be careful about while carrying these activities with the students? And what is that one thing that we all need to look out for?
Very, very interesting question, Pavan. As I said, we have been working with private schools as well as government schools. If I talk about the private schools, most of them are localized in Bangalore as of now, and that includes some schools like Valley School. There are a couple of alternate schools like Purna Pramati, and there are a chain of schools like Chrysalis and Ekya, Harvest International, Green Dot, as well as Invention Academy, Shivnadar School. These are some of the schools, and Shivnadar School, by the way, is both the Noida as well as Faridabad branch. These are some of the schools with whom we have been working for almost the last 3 to 5 years, and these schools who have been running the annual programs, which includes Ekya, Chrysalis, Harvest, Valley, etc. Once they have started, they have not stopped doing that for all these 4 or 5 years, right? So that itself gives us the confidence that this is addictive, and also the teachers find meaning in using these resources. And of late, we have also started creating these videos for the teachers, which helps them connect the observations to the underlying theory, which during the last year, the schools have been using our online platform. They have appreciated a lot of that. What's interesting is we have also been working with a large number of government schools, and what we hear from our field partners there, we have tried the model of we ourselves going as well as working with some field partners. What's most effective is to work through some field partners. So Maharashtra, there are around 40 schools spread across Mumbai and some tribal belt near Mokhada. Then Goa, West Bengal, Jharkhand, these are some of the schools where the children as well as teachers, they are a big fan of the resources that we have been providing. To answer your second question, is there something that we need to keep in mind? Sometimes it's crossing that small hurdle that has to be done by the teachers, because most of us have come out from the same system. I still remember when I had to first implement one activity with children, my biggest difficulty was not to make the generator, though that was the goal. The biggest difficulty was in cutting the cardboard. So some of these hands-on activities sometimes is a little challenging for the teachers. What we have tried of late is, the last 3 schools, we have requested the school to have one person responsible for this. So that's kind of equivalent of the lab assistant, which compensates for the difficulties which some teachers have in implementing the program with the children. Otherwise, I can't think of any other precaution which one has to keep in mind.
Thank you, sir. Jayaraman sir, I'm sorry,
Yes.
our time is up. Jayaraman sir, you can say the vote of thanks.
We have another 2 minutes to go. Am I right by my watch? Yes. I must congratulate Vishal and Projita for the wonderful exposition they have done. I know how delicate it is. It's also, there is a low cost items, but high value in terms of educational input. It needs, as they rightly said, training of the teacher to be elegantly doing it in the classroom. That's very important. You can't do an experiment in the presence of children with on a trial and error basis. So you should be an adept in the art of that exposition. That's one thing. Then what struck me, there was a question here I found. How do we make it interesting for KG, the kindergarten schools? Yes. My suggestion is slightly different from this. We'll take it up at a topic later. We have a large set of science stories for children, where the scientific methodology is introduced by science stories. Stories which are been transmuted from folk tales into science. So they are narrated and the scientific methodology is told through stories. That's one thing. Then as I was seeing the onion peel of the biology experiment which Projita showed here, my imagination was fired. I was wondering, if you peel an onion, not the Madras onion, but the larger Bombay onion, and you use it, the teacher can also demonstrate that she will cry when she peels the onion. You can't peel an onion without watering your eyes. So biology can be taught easily along with this experiment, that the chemical called allyl sulfide is responsible for causing teardrops in your eyes. So you can have a more holistic explanation, a raw information, that is allyl sulfide causes lacrimatory function in the eyes. You are doing a wonderful experiment on one side. Tie some raw experiment. The information gathering can also be done as part of it. Yes, wonderful experiments on magnetic rings, aerodynamics and hydrodynamics, action reaction, Bernoulli. You have a fascinating world of physics brought in here. And the color chemistry, very interesting. Turmeric becoming red. Yes, we used to do this under the superstition exposition campaign. We used to put a turmeric tilak over here, then dip our hand in soap, and soap is sodium or potassium stearate. So when you put soap which is alkaline, it will become red. So you can produce an intended effect by chemical reactions, or you can use blood coming out by using ammonium thiosulfate, ammonium NH4CNS plus ferric chloride. You can take a coconut and cut it and make blood come from your hand. There are stirring experiments in chemistry, which you can do to attract the imagination, then sell the chemistry behind it. First, gather the imagination, attract their attention, then explore the science behind it. There are beautiful experiments on that. In fact, Neuroscience Center at Bombay has been doing that. So I congratulate Pradeep for exciting our imagination, for engaging us for such a long time on a very worthwhile, fruitful experiment. And I'm very, very happy about it. And I'm sure this is the first toppling step we are taking. And we have miles to go. If science can be sold in the schools in this way, in this engaging way, in this exciting way, and we build the science capital at the school level, building the science capital, any word, any activity, whatever they do, doing is science, and knowing can come later. So this blending of knowing and doing, the Russellian paradigm of science is being enacted here. I'm very, very happy about it. I have very carefully watched every experiment, and I'm delighted by the exposition here. And let's all move forward with this proposition. Thank you very much, Vishal and Rajita, for your wonderful exposition. Yes. Thank
And
you.
a special thanks to Dr. C.V. Krishnan also.
Oh, Dr. Krishna is my revered guru. Yes. Dr. Krishna, are you here?
Yeah, I think we lost the link with him. So
Okay, Dr. C.V. Krishna. Yes.
yeah, he is not there. I
So,
think.
Dr. Srisan, in that happy mood, we
End up this.
will, a great day, memorable.
Next month, first Saturday, again we will host something
Yes.
very interesting session to you all.
Very good.
Vande Guru to all. Thanks for coming. Once again, happy Diwali. Vande Guru.